as we have mentioned, passwords never pass across the network, whether you're going to Amazon, whether you're logging in here, whether you're logging into Timbuktu, or what is that thing? What's the video thing? Not Timbuktu. Tofu? No, I can't remember the TikTok. There it is, TikTok. Logging in there everywhere. Your password's never passed. A hash is what's passed. And so what this lab does is creates a bunch of passwords and hashes. And we're going to use a little shell script. And I'll come back in about 20 minutes after everybody's typed all this out. No, you can copy and paste it. So I'm going to select it. And then I'm going to get it into Linux, and then we'll go through what each of this means. So then I can copy it from here. Now you can paste into Linux virtual machine, provided that you have turned the shared clipboard on ahead of time, which I didn't. So you want to turn on the shared clipboard. That means you can copy and paste from your local machine to your virtual machine, which is very convenient. I just neglected to turn it on before I copied. Now I have to copy it again. There. And you would want the one that says paste selection, I think, or paste clipboard. I always just use paste selection. Well, that's not exactly what we wanted, did we? But it's on our clipboard. We know we can get it back and forth. And actually, I don't know that we could run this from here. But let's clear that out. What we want to do is nano, right? What did I name the file? Nano create hash.sh. Yep, that's what we want to start with. Create. Now, what do you suppose SH stands for? It's a convention because it's a convention amongst Linux people. It stands for shell script. Linux does not pay attention to file extensions. We do. Just helps us know what it is. Nano is a command line text editor because everything in Linux is configured by texts and it's everywhere. There are no like secret registry databases like there is in Windows. Everything is a text file. Now in here, we can then paste our selection in here and we don't have to type it all in. Zip. Now, what the heck is going on here, you ask? Right? So let's go through it. With the ones that I don't know, Mike will know because he does Linux all the time. So echo prints it to the console.
Then it pipes to.
And I don't know what the -n means, but it's going to take this password. The vertical symbol is pipe. It's going to take this string and pipe it into this.
This thing creates hash.
And that creates an SHA 256 hash. And then that hash, and I don't know what this means, but basically
Translate, deletes hyphens from the hashes.
Okay, it deletes hyphens from the hashes.
Yeah,
This-
here to translate. It's
Okay.
kind of a change this.
And the two things pointing that way are called redirects.
Append. Yeah.
It's a redirect and it's a put it
Append.
into this file and append it to the file.
Yeah, appended.
Because there's two of them. So after this line, the hash for this password is in the text file. Then we do it again. Then we do it again. And it says insert one of your passwords. Well, what do you suppose? Let's insert, oh, password 01's already in there. There, this is a poor pass. Actually, that's a good password. Oh, let's make it even better there. So whatever text it takes it, converts it, hashes it, and stores it in our little file. Control S will save, even though that's not listed here. Control X will exit. We can type in cat, if we talked about in an earlier class, cat is concatenate. Oh, I have to create my file first. Okay, we need to run it first, sorry. I'm getting ahead of myself and not paying attention to my directions. So we've created our file, we've got it saved.
We have to run it.
Yep, there's a couple ways we can run it. One of the things we should learn about because we're in Linux is permissions. We're going to change the permissions of this, create hash, so it's an executable. Right now, it's a text file. But if we try to just type in create hash.sh, well, let's try it. It has no clue. It doesn't know that it's an executable.
And
However,
also, you know, if we do LSL to list them, we will
Mhm.
see that there is no X against that.
good idea.
file.
LSL.
Yeah,
So for something to be executable, it has to have an X in here. Now, are directories executable?
they are always executable.
They're always executable because you're moving into them. I think
Mhm.
that's the
Yeah,
best
this is
analogy
their
I've found.
function. Yeah,
Yeah, that's their function is you're storing stuff in them. You can't really execute, they're not really programs, but they're considered executable. So we need to put an X right here for this guy so it becomes an executable program in Linux. We need to temporarily have root level access. So we're in the what's called the subdoers file. And then we're going to change chmod modifies the permissions.
Mhm.
744 is secret code for making it. Everybody can run it. Everybody can run it. No, everybody can. We can change it and run it. They can change. They can run it. They can run it, and it makes it executable because of the 7.
7, yeah, makes it executable for the owner only.
Right, and we won't go into what the 7744 means right now, but this is a very common common security setting. If you want somebody else to run it, otherwise we just do 700, but this is a good one. Oh, we have to know our password. Now what happens? Did it break? No. We can run it, we can change it, we can execute it. Everybody else can only read it.
Mhm.
So 744 is like fairly common permission for something that you want others to maybe look at, but you are the only one that you want to have make changes for it.
Yeah,
And we'll get into what all these R, X, and Ws and all that means. Read, write, execute. So the owner is the first one, read, write, execute. The next one is for whatever group you've assigned to it, which is user. And the last one is for the world, for everyone, which just means people who can get to this Linux machine. All right, so we're going to type in create. Whoops.
the cat, it's not a cat.
Oh, there we go. Create hash.sh. Oh, it wasn't. Oh,
There is this little thing, yeah.
you have to do that.
Mhm.
Why Linux has you do that? That's an interesting question. You have to like temporarily get out of the directory and go back in or something. I don't know. What you're saying is the command we're using is in this folder. How about that? That's a better way to say it. So you have to do /. Hopefully I did that in the directions.
Yeah, that's correct. It will work.
ls-l. So I showed the X. And there's changing it. And change, yep, I do have the / in there.
Yeah, that's correct. Okay,
Now. Target hashes. We'll just use nano to look at it. There they are.
Mhm.
Can you tell which password is which?
It's impossible.
Yeah, the algorithm is designed so you can't reverse it. However, if I have a dictionary of hashes and I know what the password is that goes with them, I can compare hashes. So capturing a hash is like the holy grail of like getting that password exchange as a hash. If you can capture that, you can sit back with your 50,000 GPUs and crack to your heart's content and get the passwords and everything out of it. Which is what we're going to do. So we'll just say we've captured these over the network. We've captured these from authenticating to Wi-Fi, wherever we've captured these are authentication hashes that have been passed over the network. Yes, they're usually encrypted, but this is what I call a proof of concept, meaning, yeah, you're really not going to be able to hack much doing this. But we're working on understanding what's happening. So each of those hashes is the authentication hash that is the result of chopping up your password into little pieces. We can't ever reassemble the pieces, even if you have lots of super glue, but we can compare those hashes. So we need to find a dictionary file, and there's one built into Kali called RockU. And there it is, rocku.txt. It's one of the probably most famous, what's called a word list. A word list is a list of frequently used real passwords that have been, there's gazillions of lists everywhere all over the internet. This just happens to be one that they put into Kali, so you can use it to test things. So we need this gigantic list of words. Well, it says .text, .gz. So what does a GZ mean?
It's zipped.
Yep. It's using what, gzip, I think, or something. So what we're going to do is CP, copy. We're not going to mess with that. We're not going to mess with that folder. We're going to put it into our folder so we can then mess with it. So CP is copy. Then we're going to put in the absolute path. And you can use what's called tab completion, like I just typed in SH for share, which, by the way, this is on page 7. Word lists. There it is. So I just typed in the first characters of each one of them, press tab, and it automatically filled it in. Linux did. Now that gives me my source file. Any copy command needs a source and a destination. So my destination is going to be home/user, because that's my home folder. Home is where all the user profiles are stored. It just happens that my user is named user. If my user was named Bill, this would say Bill. So I've copied, I have my source file, I have my destination. There it is. There it is. I think it's red because it's compressed, probably. Like green is for execute. All right, how are we doing? Good. Okay, so now we need to unzip this because GZ, as I read in my direction, stands for gzip. So we have to do sudo because if we're doing funky things, we have to be elevated to our proper command, gzip. It's a built-in utility in Linux and lots of versions. We're going to say -d, which probably stands for decompress. And then the name of our file. Whenever we're saying a file that's in our current folder, we go /. Now it shouldn't take too long. There we go. I'm going to do a ls -l. And look at how big that text file is. Ooh, look at that thing. That's a lot of words.
134 megabytes, 140.
139 megabytes of text. So we don't want to open that up with nano because we could like blow up our whole machine. But if we do more rocku.txt,
Yeah.
yep, we can go through a little bit at a time. And these are all passwords that people have used. Some of them may be nasty, but these are all legitimate passwords people have used in the past that have been stolen by data dumps. That's where most word lists come from. So now we have this huge, I don't know how many passwords are in there. There's bunches of them. Oh, and when you're done with the more, sorry, I just sometimes do things and don't think about it. You can either press Q to quit or Control C. Anytime you're in a command line environment doing something and you want to break it, Control C will typically break whatever you're doing. So you might guess that you'd never want to use 1, 2, 3, 4, 5, 6, 7, 8, 9 as a password. Look at the first numbers are like everywhere. That's pretty funny. Well, now we have our password file. We have our hashes that we're trying to find passwords from. We're going to use Hashcat to go through this file. Are we good?
Yeah, she forgot her password. Want to help.
Oh, get into Linux? That's why I have
That is
everybody do
user.
password. Did you do password 01?
No, I didn't know I was supposed to use that.
Oh, that's why we use password 01 because of this.
Yeah, the first one is user and the second one is password. Yeah, this one is username.
This one?
Yeah, this is the username.